Alright, this is a demonstration of the flow simulation in Solidworks for the APOC duct. This is just a very general concept for illustration purposes, so let's get started. Okay, so here you can see the duct, and I have a diameter set for the inlet and the outlet. There's a cut view. So the first thing we're going to do is we're going to add another configuration. In this next configuration, we're going to add a 7-inch inlet, and this is how you do that. I'm just going to type in 7-inch inlet, and then you want to scroll down and make sure suppress features is turned on, and then add it. Okay, so I just added the two new configurations. Now let's move over to the 7-inch inlet. Ignore all this stuff right now. Let's go over to this tab, and we want to click on annotations and show feature dimensions. Now let me hide some of this stuff first. Okay, so now back in this tab you can see the dimensions here, and you want to double click on this. Previously this was set to 6, but you'll want to type in 7 here, and then click on this, and then click on this configuration, and then hit the check mark, and then hit configurations right here, specify configurations, and then choose a 7-inch inlet. And then you'll hit the check mark again, and then you'll want to rebuild it. And now if you go back to the configurations tab, go to the 6-inch, and you'll do the same thing. 6 inches, this configuration, check mark, configurations, specify, 6-inch inlet default. Okay. What this does is it just prevents these from carrying over to the other configuration. So you can see here this inlet size is 6 inches in diameter, and this one is 7 inches. Alright, now that we have the flow or the different configurations, the next step is to start the flow simulation. So I'm just checking some things here. Okay. There's the flow simulation tab. And then you want to come up and click the wizard button. And after you do that, a new pop-up window will come up. Ignore the stuff you see in the background again. So you'll click that, and then here, type in the title, and then choose the configuration that you want to use. So again, 6 or 7. This one is 6. And then hit next, and then choose inch/pound second. Click next, and then you're doing internal, exclude cavities. You don't need to check any of those. Next, and then gases, double click air, keep everything as is, next, and then for your roughness, you can do an analysis here for the roughness of the 3D printed material. This is just an option if you want to. And then for here, just make sure these properties are standard day conditions, and then hit finish. Alright, so after you click finish, this will pop up with a flow domain. It's probably going to ask you to create lids, so that'll pop up, and then you just click on these surfaces to create the lids. And these need to be flat surfaces for this to work. And just hit the check mark. and now your computational domain will pop up. And then from here, there's the domain. Now we can start on the boundary conditions. So the first one is going to be the surface, the inlet, and you're just going to choose environment pressure. And again, check these conditions down there, and then hit the check mark. And the next one is going to be for the outlet condition. So insert another boundary condition, choose outlet mass flow, and then put in 0.64 pounds per second. That just comes from the JetCat data sheet for the P100. And I'll choose that surface. And that should be it. And then hit the check mark. And now we're going to go to goals. Okay, now we need to insert surface goals. So go over to goals, insert surface goal, and then choose the inlet, and we're going to choose a total pressure average, and then we're going to name it as that, the inlet total surface pressure. And then we're going to do that again for the outlet. Again, total pressure average. And you can see there are many different options you can use. If you want temperature, if you want a mass flow rate or velocities. Again, outlet, total surface pressure. And then now we need to create a equation goal so we can get the total pressure drop through the system. So insert equation goal, and this is just going to be the average total pressure drop. I'm going to name that the equation. And then for the expression, it's pretty simple. You just click the inlet minus the outlet, and then you hit the check mark. And now you have an equation for the total pressure drop through the system. Now for the global mesh, you can keep this simple because there'll be some refinements later on, but you can choose 3 or 4. Just keep it automatic. That's a good starting point, and you can see the basic mesh. Okay, now that's set up. Okay, so now just click the wizard tab again and do this for the new, all that for the new configuration. Just choose 7 in the configuration. After you do that, you can see that the new one will be added. So now we need to do a refinement for the controls. So click control or calculation control options, and you'll need to click the refinement tab first. Actually go here and choose all satisfied. I want to reset this so I can show you. So on the first one, just click all satisfied, and then go over to the refinement tab and choose 5. This means so for each flow domain, it can subdivide 5 times. For the max cell size, I'm going to put in 2 million. A good rule of thumb is 1 million cells per 6 gigabytes of RAM for the computer. I'm going to change the tabular to periodic and keep that at travels. I'll go back to this tab. Just type in 5 here. Extend that. Now I'm going to choose this to be 0.5. You can choose this to be whatever you want. 0.5 works pretty well. For the saving, just do wall clock, and it'll save every 3600 seconds, and then click OK. And now you can run the simulation. So we're going to run the 6-inch first. And then you'll see a new window pop up. So you can see it's starting the iterations. Right now this is a graph of total pressure with the mesh. I'm going to X out of this tab. If you want to add a new goal plot, just do this. Here's the average flow pressure. So I can delete this one I already had on here. But yeah, so now you can see the plot of the average total pressure. And here's just some more information: total fluid cells, CPU time, the travels, etc. Again, the refinements and iterations. This is per travel again. Here's the total pressure drop, and just a cut plot. Same thing, but with the mesh. Now say you want to add a different view. That's how you do this here. This is the right plane. That quality size worked well. Just say we wanted to do just regular pressure. Give it a second and it'll pop up. It's just calculating. So now here's this cut view. Many different options with this stuff. You can do velocity, mass flow rate, basically any of those options that were shown earlier. Here's our list of goals. So these will converge. Sometimes after each travel, these will back off and they won't converge, so just give it a good time. I would say for you guys, maybe 1 hour per simulation. You can see on that mesh that they refining each travel, so those will just keep refining each time. Okay, so it solved and we're back in this. There is the value. Results, make sure to load the result just by right clicking on results and hit load. We're going to insert a cut plot. Make sure it's on the right plane or whatever plane you're using on. Make sure you have the cut view so you can see it, and we're going to choose contours and streamlines. Pressure, we'll do 100 here. That's basically like the clarity, how well you can see the different colors. And check mark, and we'll load it. And you can see the results. I think I'm going to change this. Keep it at pressure. Change this to vorticity. And hit the check mark again. And now you can see the vorticity in the system. So you can see these values, they don't change much from the max to the min. So now we'll go down here to goal plots and insert, and then we'll just click the average total pressure drop. Check mark. And then you'll do the exact same thing for this one. So you might have to go through this control tab again. You can see these if you missed it the first time. The more max cells you have, the better results, the more accurate results you'll get. And now we're going to run the 7-inch inlet. Again, a new window will pop up. Just got to give it some time. Pretty sure it's already loaded. I just haven't clicked on the correct plot yet. There you go. So that yellow describes some of the flow separation that you can see. I'm going to add the goal plot for this one. And I'll let this converge, and then I'll stop it and then go back to the main window. So now they're both solved. I did the exact same thing for the cut plot and the goal plot, and now we're going to try to compare the simulations, the results. So I just come up here to the search and type in compare. And this allows you to compare the results for each of the simulations. So I can compare the cut plot and the average total pressure drop, and then make sure you choose both the 7-inch and the 6-inch, and then hit compare. And then you can click on the cut plot, see the comparison between those, and then here's the goal plot. Now for here, for some reason, this didn't load. You guys are just going to have to play around with it. There's a bunch of different options. Just do some research. I think it has to do with my computer why it's not working. But they're all different types of things. So if you run 6 different simulations, you can highlight the max between the 6, the minimum, the average. You can plot them against each other. You can export this stuff to Excel and have it plotted there. Many different options you can do. Now, if you want to get the data directly, a couple ways you can do that. You can just go back to this goal plot, and then just click on show, and you can get your values here. So you could do this for each simulation and grab the values from there. You can also export it to Excel and get the data there. So there's the summary, there's the plot, and then there's the data for the plot. So many ways to get the data. If you guys just do the research for the comparison tool, again, it'll make comparing to different simulations much easier. But yeah, this is basically how you do the flow simulation to find average pressure drop through a duct.